Okay, for this video we're going to look at expectation algebra, and we're going to look at how this works and what it means. So we're going to start off with a basic discrete random variable. This one here has three options: 0, 3, or 6. Right? If we put those options together, we can then look at our expected value. Our e of x is going to be 0, 1.8, 0.6, which gives us 2.4. Our e of x squared, if we put that together, is going to be, this x squared is 0.936. So we have 9 times 1.8 is 5.4. It's not. 9 times 0.6 is 5.4. That's what we should be doing. 36 times 0.1 is 3.6. And 0.3 times 0 is 0. So that gives us 9 as our e of x squared. And so our variance, which equals e of x squared minus e of x squared, equals 9 minus 2.4 squared, which equals 3.24, and our standard deviation is 1.8. I chose this one because it had some nice numbers. So our mean is 2.4, our standard deviation is 1.8, our variance is 3.24. What I wonder is what happens if we were to double everything there? Or what if we were to add something to it? So we're going to have a look at something, and to look at this best, the first thing I want to do is I want to actually have a look at a visual as to what this one looks like. So we're going to look at a visualization, and then we're going to look at what happens when we multiply it. Okay, this graph I've got here is a visualization of what if we did 100 trials with that random variable, what we would expect to see. We'd expect to get 30 zeros, 63s, and 10 sixes. Right? So that's what it would look like. And we'll just remind ourselves that our mean was 2.4, our variance was 3.24, and our standard deviation is 1.8. Right. Now, if we doubled everything, what we would expect to see would be our probability tree would look like this. Our probability distribution table would look like this: 0, 6, and 12. And we would expect that to be 0.3. That would be 0.6, and that would be 0.1. So it would give us an expected value of 3.6, 1.2, 4.8. This is x, this is probability x equals x. And then we're looking for our e of x. And then underneath here, we're going to look at our e of x squared. There's actually a shortcut to finding e of x squared, which is just multiply x by e of x squared. So e of x, so 6 times 3.6 21.6, and 12 times 1.2 is 14.4. So we add them up together, we've got 36. All right, and so then if we do that to find a variance, let's go this way. The variance of x, or this is actually 2x because we've multiplied everything by 2, is 12.96, and the standard deviation is 3.6. And mu equals 4.8. Now if we compare that up above here, the mu is now double what it was. Right, so E of x was 2.4, E of 2x, or mu, so that's E of 2x. What's that? The variance is 4 times, so it's 2 squared times that, and the standard deviation is double. Right. So that's kind of straightforward, and if we look at it visually, we can see what it looks like. Here it is. If we look at this one here, we see we've got E of x, and then we've just doubled it to get double it, and we see that everything is wider apart. We would expect our mean to have moved up. It's just taken the whole thing and spread it out a bit. So we see here it's all punched up within 6. Here it's twice as wide. Right. Our center was here at 2.4. Our center is now here at 4.8. So it's just everything's moved out. And that's kind of what we would expect to happen if we look at the graph when we do that. Now what if we were to just add 1 to it? So instead of going 0, 3, 6, we would instead go to 1, 4, and 7. Well, if our x is that, our probability that x equals x that back. Right, it's still going to be 0.3, 0.6, 0.1. Right, if we work this in, it turns out our E of x, or here of x plus 1, is equal to 3.4. The variance of x is 3.24, and the standard equals x plus 1. The standard deviation, or actually it might be better to use this notation, x plus 1, the standard deviation is 1.8. This time the mean has changed, but the standard deviation and variance haven't. And if we look at the graph, we can sort of see why. Here we have the original, and here we've added 1 to it, and what we see is actually not much has changed. It's just moved everything up 1, so it's still spread out just the same, but the median is just going to, the mean is going to be moved up by 1 because everything's been moved up by 1. Okay, what if we looked at 3n plus 2? So we're going to scroll down, have a little bit of a gap here. Right, so what we're looking at here is that we've got 3x plus 2. I'm going to find the probability that x equals, well, that 3x plus 2 equals that. Right. So that's going to be 2. 3 times 3 is 9, plus 2 is 11. 3 times 6 is 18, plus 2 is 20. So for this one here, we've still got 0.3, 0.6, 0.1. So we multiply it out to fit in. We're going to find our E of x, our standard deviation, our variance, and our standard deviation. Right? Now, if we looked at the last couple, we'll remember when we multiplied it by 2, the mean, the expected value multiplied by 2. When we added 1, the mean expected value added 1. So we would expect here that we'd go from 2.4. We could go 2.4 times 3 plus 1. Times 3 plus 2, sorry. We'd expect our expected value to be 9.2. Let's see whether or not that comes out. Right, so we've got 0.6, 6.6, and 2. And we add them up, and sure enough, what it's come out to? 9.2. Right. Now our E of x squared, 1.2, that's 72.6 and 40. So altogether, we've got 112.6, 113.8. So we've got E of 3x plus 2 equals 9.2, our variance. $113.8 minus 9.2 squared equals 29.16. And our standard deviation is equal to 5.4. Now if we compare that to what we had initially, we had 2.4. The variance of x equals 3.24, and the standard deviation of x is equal to 1.8. So if we divide these here, we'll look what's happened to it. Here what we see is that 2.4 times 3 plus 2, but this one here is just 3.24 times 9. I wonder where that 9 might come from. Well, we look at the standard deviation, and that's 1.8 times 3. And if you remember that we're squaring, or the standard deviation is a square root of the variance, that's where that comes from. So we end up with we can ignore what we add on, and we just square the multiplier. We square the 3 because it's 3x plus 2, so that's why we multiply it by 9. Okay, now the last situation I want to look at is one quite different. And this is where instead of having multiplying the random variable by 2, we're having two different random variables. So we're adding together effectively an x1 and an x2. And when we do that, what we're going to have is we find that the probabilities don't just end up doubling, right? If we look at this graph here of it, we have there's the 3x plus 2 graph. If we look down here, we have our x, and when we add them together, we end up creating a much more diverse probability distribution to get this one here. Now, if we look at this, we notice that it's a lot more spread out than just what our 2x was. If we look over here, here's the 2x. It's a lot less spread out rather than the 2x. We've got all those numbers that are in the middle. So we have the 3s and the 9s, whereas we didn't have any of that. And we've got less on the outside. So we would expect our variance and our standard deviation to decrease. which is exactly what happens. But interestingly, the middle is still the same point. So what we have here is we write it like this. As we call our two random variables a and b. It's e of a plus e of b. Right, that one works just how you'd expect. But the interesting one here is the variance of a plus b is the variance of a plus the variance of b. Now that looks similar to what you'd expect, but remember we squared it for when we did it 2a, it ended up being 4 times the variance of a. So the result of this means that when you have two random variables, our standard deviation does not equal the double the standard deviation. Instead, the standard deviation is the square root of those two variances added up, right? Which is not the same as the standard deviations, the two standard deviations. So this is really where the variance comes into its own, is that the variance allows us to combine different random variables. Okay, here's your homework for this task. E of x is 2.5, variation of x is 2.25. E of y, so there's two random variables, x and y. E of y is 1.8, and the variance of y is 1.44. I want you to find the mean, variance, and standard deviations of 2x plus 2, 3y, and x plus y.